Good morning. Today's lesson is on matrices. So first of all, we need to know what is a matrix. And a matrix is really just a rectangular array of numbers that's written in brackets. So it might look something like this. It's just a way of organizing numbers. Okay. Each number inside of that matrix is called an element. So this would be an element. So we would have a total of 6 elements. Now, sometimes you're also talking about them in terms of their location. So if we called this matrix A, I would say A11 would be the number 1. So that means row 1, column 1. So if I said A21, that would be row 2, column 1, which would be the number 4. So if they talk about it in terms of the location of an element, if it's matrix A, they'll use a lowercase a. The first number represents the row and the second number represents the column. When we talk about matrices, we talk about them in terms of their dimensions. So we talk about them in terms of rows and columns. So for instance, if you look at matrix A, it has 4 rows and 2 columns. So we would say its dimensions are 4 by 2. It's always rows by columns. Matrix B, it has 4 rows as well, but it has 3 columns. So this would have a dimension of 4 by 3. So again, that's our size of our matrix, and our dimensions are what we just talked about in terms of the 4 by 2 and the 4 by 3. Now, when we get systems of equations, which was the last unit we did, we can create what's called an augmented matrix. So what we're going to do is we're going to set up our brackets. And we're going to pull off our coefficients. So we're going to pull a 3, then a 4. And then we're going to do a vertical line, and then we're going to put a 1. Then on the next row, we would have a 1, a -2, and a 7. We can do the same thing on the bottom one. Again, you're pulling off your coefficients. So it'd be 2, -1, 4, and then -6, 3, -12. So this first part is called the coefficient matrix. The second part is called the constant matrix. So you're augmenting them, you're joining them together. Now, when you're solving systems with matrices, what you can do is what's called row operations. So when we're talking about this, the capital R means row. This little 1 means whatever row you're talking about. So this subscript I could be row 1, it could be row 2, depending on how many rows you have. So if you are going to switch row 1 and row 2, you are interchanging them. And so you would do a double arrow. So the notation to switch row 1 and row 2 would look something like this. Row 1, double arrow, row 2. Now, you can also multiply a row by a constant. So if you do that, this K represents the constant. This is whatever row you're multiplying by. Now, this is part at the end is the row you're replacing. So which row are you putting that into? Now you can multiply by a row and then add it to another row and replace it into whatever row you're indicating. So the arrow, like it says down here, means it's replacing it. You're putting that in. Now, another thing that we have to be able to do is recognize if it's in reduced form. This is also called row reduced echelon form. So it says each row consisting entirely of zeros is below any row having at least one non-zero element. So if you have a row of zeros, it has to be at the bottom. The next thing it says the leftmost non-zero element in the row has to be a 1. So the number at the farthest left of every row has to be a 1. All other elements in the column containing the leftmost 1 are zeros. So, and I'll show you an example here in a second. And the leftmost row is to the right of the leftmost 1 in the row above. So an example of something in row echelon form could be something that looks like this. So your ones here in the diagonal, if you have zeros everywhere else, then that would indicate that you have solved this system of equations. So if you were talking about x, y, and z, you would say x is 3, y is 2, and z is 4. But this is what's called row echelon form. If you had a row of zeros, like it says, it has to be in the bottom. So if we look at this, this is an example. This is not in row echelon form because remember the leftmost one must be to the right of the one above. So what we have to do is we have to interchange. We have to switch row 1 and row 2, and remember the notation for that would look something like this. And that would give us a matrix that looks like this. And so this matrix now is in row reduced echelon form. So what we have to do with this is to be able to solve. So we're going to have to create an augmented matrix and solve. So our augmented matrix here would be 3, 4, 1, and then 1, negative 2, 7. So our objective is we want to get our matrix to look something like this. We want ones in the diagonal, zeros in the other diagonal, and then numbers on the other side. So the first thing I would do is try to get this 1 in this top spot here. So I want a 1 right here. My easiest thing to do here is to switch row 1 and row 2. So that would give me 1, negative 2, 7. We're not changing anything, we're just switching the rows. And I would get something that looks like this. Then you work your way down. Now what I want to do is I want to make this bottom number in my matrix 0. So to do that, I'm going to take row 1 and I'm going to multiply by negative 3. And I'm going to add that to row 2, but then I'm going to replace that in row 2. So my row 1 is not changing. It's staying the same. Multiplying by negative 3 and adding 3 gives me my 0 that I wanted. Negative 3 times a negative 2 gives me a 6, plus 4 is a 10. The next one, multiply negative 3 times 7. That's going to give me negative 21, plus 1 is a negative 20. Now, then you work your way over. Now I want this number to be a 1. And so to do that, we would take row 2 times 1/10. You can't divide with matrices. So you would write it as multiplying by 1/10. Then you're replacing it into row 2. So I'm going to move over here. My top row again is not changing. But I would have 0. I'm going to divide or multiply by 1/10, which is going to give me a 1 and a negative 2. Then the last one that we want to change is this top one, and this top one we want to be 0. So we're going to take row 2 times 2 and add that to row 1 and replace it in row 1. This time our bottom row is not changing, so I'm going to leave it the same. 2 times row 2, which would give me 0, plus 1 is just going to give me a 1. 2 times 1 is 2, plus negative 2 gives me that 0 that I'm looking for. 2 times negative 2 is negative 4, plus 7 gives me a 3. So that would give me my solution that x1 would be 3 and x2 would be a negative 2. There are also ways to do this on the graphing calculator. If you do not have a graphing calculator, you can use the matrix calculator in Desmos. If you need any help, please let me know. Have a great day and have a nice weekend.